So, what is stoichiometry? Stoichiometry is calculation based on reactions. So, calculations based on reactions involve limiting reagent concept, mass mass relationship, mass volume relationship, mole mole relation, or volume volume relation, depending on what kind of data has been given to us. So, if let's say volume of one entity is given and mass of another is to be calculated, we will use mass volume relationship. If volume of reactant is given and volume of product is to be calculated, we are going to use volume volume relations. And similarly, if moles of one reactant is given and moles of product or moles of product is given, we need to calculate moles of reactant, we are going to use mole mole relationship. And what is limiting reactant? You are going to see this very often, limiting reactant or limiting reagent. So, if you have a reaction in which more than one reactant is there, let's say there is A reactant and B reactant, and you require each in certain ratio, and quantity of one is limited or that supply is limited, then that reactant is going to be the limiting reactant. A limiting reactant is always completely consumed in the reaction. So how you are going to calculate which one is limiting reagent? Firstly, limiting reagent will be required when two or more than two reactants are there and different data is given. Then you will do one simple trick. Just try it out. Trick for limiting reactant. Trick for limiting reactant is like is as below. What you do is, for reactants given, if I take N2 plus 3H2 and it gives 2 ammonia, then if I give you data given is I take 10 moles of this and 10 moles of this, right? Data given is in terms of moles, 10 mole, 10 mole. Then what you do is, the coefficient here is 1, here coefficient is 3. Balance reaction. Write a balance reaction and divide number of moles by coefficient. Divide number of moles by coefficient. Like, let me explain it to you. For nitrogen it will be 10 by 1. For hydrogen it will be 10 by 3. So for whichever reactant you get the lesser value, that will be limiting reactant. As in this example, for hydrogen we get 10 by 3, for nitrogen we get 10 by 1. So limiting reactant here will be hydrogen. This is going to be your limiting reactant, right? So that is the simplest trick you can apply to find out limiting reactant. And when you will need this? When two or more than two reactants are given and the quantity of each is given. Then find out which is the limiting, and all the calculations will be done through limiting reactant. Alright. And what is explained over here is empirical formula and molecular formula. So what is empirical formula? Empirical formula is simplest ratio of atoms. And what is molecular formula? It is the actual ratio of atoms. Example, let me give it to you, is if I take C6H6, this is the molecular formula, and empirical formula will be simplest ratio, and that will be C6H6 is actual formula, and if I divide by 6 you will get CH. This is empirical formula. Similarly, for glucose, if I take C12 C6, for glucose I take C6H12O6. This is the molecular formula, and I divide this by 6, you get CH2O. This is empirical formula. So simplest ratio is empirical formula, and actual number of atoms are represented by molecular formula. And what are the relations? Relations, just remember this: molecular weight equals to twice of vapor density. And what else? Just remember, molecular formula molecular formula equals to n into empirical formula. What is N? N will be molecular mass divided by empirical mass. Molecular mass divided by empirical mass will give you N. From here, you can calculate what is the molecular formula. Molecular formula will be N into empirical formula, right? And N is molecular mass by empirical mass. So that's it.